Assalamualaikum warahmatullahi wabarakatuh. My name is Revanza Zacharyas Jadera. I'm from MB-48-11. I will explaining about this question about marginal cost, marginal revenue, max profit, and quantity of the max profit. So we already know from the question we got total revenue for equal minus 0.2 quantity and plus and then 100 and TC 0.03 quantity and 6,000. Okay, we're gonna move on to A. We get S for the marginal cost and marginal revenue. For the marginal cost, we have a formula. Your formula is like this. So we're gonna input the TC to here. And for the marginal revenue is we have TR included to function. So the answer is minus 0.4 quantity. Okay, already had in here. Okay. So we're gonna going to number B. How to get the quantity of the max profit? We need to have the formula. The formula is MC. The formula is here. So we're gonna input the number 8 to here. Okay, sorry, I wanna explain. So for the marginal revenue is like here. Okay, I have a miscommunication because the TR has 900Q. So the function is like this, and then we input it into this formula. MR equal MC, marginal revenue equal marginal cost. So when we get this, we need this to input like this. Here is minus, and this is minus, and this is minus 2. So we gonna ending with this kind of formula here, and from here we get the answer is 10,000 because the Q is quadrant. I need to input here. Okay, so we need to Akhtar. The result is 100. So the Q is 100 for the maximum profit. Okay, cut. Yeah. Okay, so we already know the quantity of the maximum profit at the question number B. So we can continue to answer the number C. So the formula is we're gonna find the profit. So we're gonna find this formula equal TR minus TC. Okay, this is the formula. So we just gonna input it like this. PR minus 0.2. Why I'm putting 100 in here? Because we already had the quantity for the maximum profit. Okay, so like this and like this. So you just gonna calculate it. Now we're going to TC 0.03 minus 0.3. Sorry, I forgot to input the. So we got 88,000 from here, and we got 34,000 from here. Because the formula is here, so we can maximum profit is 88,000 minus 34,000, and the answer is 44,000. So it's the maximum profit of a quantity of 100 quantity. Okay, thank you. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Avarell Refazzy and now I want to answer the number 2, and the equality is z equals 16x plus 30y minus x exponent 2 minus 3y exponent 2 and minus xy. And in this equality we must find iris the equality local maximum, local minimum, saddle point or reflect point. Okay. So the first step is we must do derivative this equal dx per dz per dx equal 16 minus 2x minus y, and then dz dy equal 30 min 6 y min x. Okay, this is the first step. So we must do derivative this equal, and then the step 2 is we must do equal this derivative to 0 like this. Equal 0 and this one 30 minus 6y minus x equal 0. Okay, this is the first step. This is the second step. Okay, cut dulu ntar. Okay, after we equal to 0, we must substitute into the second equation like this. Then after this we must to put the number, sorry, so we must rainbow multiply first like this. 6 multiply 16 and 6 multiply 2x, so the answer is 30 min 96 min 12x min x equal 0, and then we must put the 30 and 96 to here, so like this, 12x min x equal 96 min 30, 66, and then in here 11x 66, then x equal 66 11, and the answer is 6. So the x is 6, and we must find y. How? We must put the 6 in first equality like this. 16 min 2 equal 6 min 1 equal 0. 16 min 12, which means 4, and then like this. So the critical point is 6 and 4, like this, 6 and 4. After we find the critical point, now the step 3 is we must find the partial derivative, second partial derivative. So we just like this. In here minus 2, and then DOSEN do exponent y equal this one min 6. Okay, after we find the second derivative, we must calculate the determinant of the Hessian matrix. The formula is like this: D equal Z x x E y y equal int Z x y exponent 2. Then we only put this one minus 2 and minus 6 in here like this, min 2 multiply min 6 and min 1 exponent 2. So the answer is 11. After we find the Hessian matrix, we must apply the 11 to the second derivative test. Okay, since D equal 11 and 11 is more bigger than 0, and then zxx is minus 2, which is more smaller than 0. So we can interpretation this equality is a local maximum. because the critical point at 6 and 4. So yeah, that's it. Maybe I can interpretation again. The function of z equals 16x plus 30y minus x exponent 2 minus 3y exponent 2 minus xy is a local maximum at 6.4. So that's it for me. Sorry if I not clearly at English, and yeah, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Firdaus, and I will answer the next question about price quantity for maximize the profit and search the profit. And from the question we have Px 36 minus Qx and Py 40 minus Qy and Tc 120 Qx plus 20 Qy. And the first step is set up the revenue function. First, we multiply the price by quantity for each good to get total revenue. The formula for TR is Px multiply Qx and plus Py multiply Qy, and put the Px and Py to the formula. And then this is the TR. And then the next step is create the profit function. Next, we subtract total cost from total revenue to get the profit function. And the formula for profit function is TR minus TC. And we have TR and TC, so we put into the formula. And then the next step is we combine the same variable and we have the profit function. And we have the Qx and Qy, and then we put into the TC and TR for search the maximum profit. TR is 0, and then TC, sorry, the TR is 300, and TC is 200. And then we search the maximum profit, and the formula for maximum profit is TR min TC. And we put the TR and TC to the formula. 300 minus 200, and the maximum profit we have is 100.
Assalamualaikum warahmatullahi wabarakatuh. So hello everyone, my name is Hutagalung. So on this video I will explain about a question. So the problem is you want to minimize or maximize a function, but there is a budget limit. So the budget limit is what? Budget limit is 2x plus y equal. So this is will be used in the Lagrange function. So step 2, the function you want to optimize is function x and y equal 4xy minus y quadrat. So now you must add the constraint with Lagrange multiplier lambda. So function x, y, and lambda equal 4xy minus y quadrat, and you can put plus lambda. So the lambda is 2x plus y minus 6. So on the next step you must multiply the lambda, the rainbow multiply. So the result is 4xy minus y quadrat plus 2x lambda plus y lambda minus 6 lambda. Okay. So the next step, you take partial derivatives. So now you take the derivative of function with respect to x, y, and lambda. So derivative with respect to x, we can write like this: function x, we can write like df per dx equal 4y minus 2 lambda equals 0. So we can solve this problem like so you can write again 4y minus 2 lambda, and you can put it 2 lambda on the right side and 4y to left side. So it will be like this. So we can we have to search, we have to find the lambda. So lambda equal so lambda equal 4y per 2. So the lambda is 2y. Alright, so this is the result. Lambda is minus 2y. So this derivative with respect to x. So right now we have to find derivative respect to y. So we can write like this: df per dy equal 4x minus 2y plus lambda equal 0. So derivatives with y is n like this. So next we will find a derivative respect to lambda. So you can write like this: df per d lambda equal I'm sorry. For derivative respect to lambda, you can just write it like this: 2x minus y equal 6. Derivative respect to lambda is just the constraint. So on the next step, we're gonna solve the system of equation. So we're gonna substitute a lambda, this lambda that we find it earlier. So we substitute this lambda into the derivative for y. So we substitute into a derivative y. So we can write like this: 4x minus 2y plus the lambda is mean to y equal 0. So we just plus this minus 2y plus minus 2y. So 4x minus 4y equals 0. So we can see we gonna put it the y on the right side. So the 4x equal 4y. So if you can see, the x and y is the same number. So so it's the interpretation is x equal y. So the final step, the final substitutions. So we're gonna now we gonna substitute x equal y into the constraint. So these constraints, now we want to substitute x equal y into this. So we can write like this: 2x plus y equals 6, or 2, because we can write like 2y plus y. Why I write the x to y, because before this, if you can see, x equal y, so we can change the x into the y. So 2y plus y equals 6. So 3y equals 6. So the 3 we can put it on the right side. So y equal 6 per 3. So the result is 2. Now, if you can see before this, x equal y. So in this substitutes, the result is y is 2. So the x is 2. So thank you very much for your attention. Maybe I have many mistakes for the speak because my English is not very well. So thank you so much for watching and see ya.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ibrahim, Reksa, Wicaksana from MB-48-11. So today we're going to answer the question of this. So given the demand function for product X and product Y, we have to answer the question A and B. So the question A is find the four partial marginal demands. The question B is what is the relationship between the two products? Are they complementary, competitive, or neither? So we're going to answer the A first. To answer the A, we have to find the derivatives of the product X and product Y, okay? let's move to the product X first. So D, do Q X and do P X. The do QX per do PX equal, from what we see, so in the product X, then in the price X is only 2px. So when we derivatives it becomes 2 minus 2, my bad, minus 2. And next we're going to find the py from the product X. That's it, qx. Do qx per do py. Okay, from what we see here, okay, sorry guys, this is the real question. I miscalculated for a second. So let's continue to do py. Okay, so when there is no numbers, only variables, it means the py, the price y, is 1. Okay, so when we derivatives it became 1, because when we derivative something, the py is gone. Okay, there's only 1. Okay, let's continue to the next one, is the product y. So product y, do q y per, so we're going to take the px first, the price x, do px. Okay, from what we saw, same for before, same from before. When there is no numbers, it means 1 again. Same with the do py, it means 1. Okay, next we're going to find the price y and the product y. Do q y per do py. So when we saw this, there's a minus, so we make it to -1 because there's a minus in it. And here there is a plus, so it's +1. Okay, so this is the answer for the A question. Next we're going to answer the B question. What is the relationship between the two products? Are they complementary, competitive, or neither? Pause. Okay, sorry guys, I forgot to explain to you guys what each of these things mean. So this means the marginal demand of X with respect to the price of X, and this means the marginal demand of product X with respect to the price of Y. Same with here, it means the marginal demand of product Y with respect to the price of X, and this means the marginal demand of product Y in respect with the price Y. Okay. Next we're going to answer the question B. Okay, next we're going to answer the question B. For answer the question B, we have to determine the relationship between the two products represented in the sign of the cross partial derivatives in here. So we cross it from Q, do QX, and do PY, and do QA and do QY per do PX. So this is the answer. They're both is positive, okay? So before we answer the question, I'm going to explain to you guys the complementary, the competitive, or neither, ambiguous. Okay, for first, we're going to explain to you guys complementary. So complementary is if the cross partial derivatives are negative, an increase in the price of one product reduce the demand for the other product. This indicates a complementary relationship. So, complementary. And next we're going to explain the competitive. So the competitive is if the cross-partial derivatives are positive, an increase in the price of one product leads to an increase in the demand for the other product. This indicates a competitive. And ambiguous is if one is positive and the other is negative, so we cannot find the relationship in there. Okay. So remember what I said from what we saw. The dou qx per dou py is 1, it's positive, and the dou qy and per dou px is 1 and it's positive 2. So when the 2 is positive, it's what? It's competitive. My bad. Yes, it's competitive. It's competitive. So when here, it's competitive. Okay. Wait. Let me raise it for a second. Dou qx per dou py is 1 and dou qy per dou px is 1 too. It's positive. So the conclusion is, since the both cross-partial derivatives here are positive, it means the dou qx per dou qy is more than 0 and dou qy per dou px. Wait, I'm sorry. Yeah, dou q. I mean dou py. Okay. The dou qy and the dou qy per dou px is more than 0. So this means the product x and the product y are competitive products. Okay, so that's the answer for for B. Okay, what is the relationship between the two products? Are they complementary, competitive, or neither? So it's competitive. Okay, competitive. Okay, that's all for today, guys. Thank you for listening and goodbye.